Statistics, this is the video for the test 4 review, your final exam. The first couple problems are going to deal with linear correlation. This was the chapter 10 material. So number 1, we're told our correlation coefficient 0.9676, which I've got a suspicion is probably going to be good enough because remember 1 is a perfect line, so it's really close to that. We're also told the regression equation. We'll see if we're going to deal with that in just a second. So in part A, we have a 0.01 significance level. Is there sufficient evidence of a linear correlation? So we've got to count how many points we have. 1, 2, 3, 4, 5, 6. So n is 6, and we're going 0.01. So on the linear correlations, n is 6 for 0.01. We have to be 0.917 or better. We are better than that. So for the first part, yes, there is. And the reason being is because the absolute value of R is greater than 0.917. Now, I put absolute value because remember, we could have a negative R, but you always just want to look at its magnitude, which is absolute value. So since it is sufficiently linear, the best predicted price of a 0.6 carat diamond, well, since it's sufficiently linear, I can use the equation of the line and I can plug that in. So I would just be popping in that 0.6 into the formula. So it'd be 7177.0213 times 0.6, and then we're adding on that negative 2006 number. If you run those numbers, you'll end up with about $2,299.23. Now, part C is a little more theoretical. What will be wrong with using this equation to predict the price of a 2 carat diamond? What's wrong with this, and we talked a little bit about this, but it's been a while, is that 2 is outside of our range. If you look at my weights, the lowest weight I have is 0.3, the highest is 1. So if you think about this, of what the graph would look like, I'd have 0.3, I'd have 1.0, and apparently this goes pretty good, pretty close to a straight line. I don't know what happens though all the way out at 2 carats. I don't know if that linear equation holds. Maybe I would assume that a 2 carat diamond is very hard to find, so probably my thought would be that maybe it exponentially increases. I don't know, but we don't know that, so we can't do it. So the problem is that 2 is outside of that. 2 is outside of our scope of the available data, so it would not be appropriate to use it. For number 2, we have first, just like on the previous one, have to figure out, are we sufficiently linear? So I got to count how many I have, which if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 10. And I'm using 0.05 significance. So 10 and I'm using 0.05. That means I have to be at least 0.632 for my R value. But I've got 0.450. So the absolute value of R, I'll just write it over here, this time is too small. It's below, again, my threshold was 0.632. So it's not linear. So that means I cannot use the equation of the line. Basically, the equation of the line is worthless. The only thing I can do is average the y values. So average the heights. So I don't even use this 0.7 that they gave me. I don't put that in anywhere. I just take the average of the y values. I would just add those up and divide by 10. So the mean of the y's, you add them up, you get 32 divided by 10, 3.2. That's the best we can do. So we don't use the equation of the line because it's not linear. Looking at number 3, now we're doing a goodness of fit test. The null is basically that it agrees with the claim. And I have these better written on the PDF of the review answers. Basically, the claim is that injuries, non-fatal injuries, occur with equal frequency on different days of the week. So basically, the null would be injuries equal frequency by day, equal F for frequency by day. And the alternative would be not that all are different, but at least one day is different. So at least one day different. And again, I have them better written on the PDF of the answer key. Letter B is kind of a trick question. Is it left-tailed, right-tailed, or two-tailed? Chi-square stuff, which is what we're doing in this goodness of fit, it's always right-tail. Because we're always cutting off somewhere and then looking to the right of that. So it's always, always, always right-tailed. So the bulk of this is finding the test statistic. Remember, to find the expected, since it's saying equal frequency, I want to add up my observed numbers and divide by, I have what, 5 days in the week. So if you add those up, you get, let's see, what number do I get there? You get 107. Divide that by 5, and my expected is 21.4 each day. 21.4 all the way down. Then I run through all of these calculations, step by step, observed minus expected. To give you these results. Some of them are negative, though. The way we take care of that is we square everybody. That will give me the next column. And the last column is to divide each one of those blue numbers by the expected. So I'm going to be dividing by 21.4. Again, I'm going to take them to the 3 decimals, which actually for the first 2 numbers, it rounds it to 0.120. To actually get the test statistic, the chi-square test statistic, I sum all these together. That'll give me my chi-square, which is a tiny one, so I'm feeling like I'm going to fail to reject, but we still got to check. For letter D, the critical value, okay, so that's based off of how many categories I have, which is 5. So the degrees of freedom would be 4. Degrees of freedom is 4. I believe this was a 0.05 significance. So now we're going to our chi-square table. And I decided that I was going 4 degrees of freedom and 0.05. So 9.488 is my critical value. The critical value is 9.488. That is a 9, kind of. So if I look at my little graph that I drew, anything beyond 9.488 is weird. Weird means reject. My chi-square value is less than 1, so it's definitely not. So my chi-square value is not in the weird region, so I do not reject. So I fail to reject. So I am not rejecting that they are equal frequencies. That basically is saying I do think they are equal frequencies. Because if I'm not rejecting, think of it like a double negative. If I'm not rejecting, I'm kind of accepting. So it appears injuries occur with equal frequency by day. Equal frequency by day of the week. Which, if I look at my numbers, they're pretty close. 19, 21, 21, 23, 23. They're all pretty close, and the chi-square value allows me to see that as well, that yeah, they do feel pretty close. Number 4 deals with the test of independence, or the contingency table. Now, the good thing about number 4 is that I don't have to do any of the heavy calculation. It's been done. Be careful, there is a problem on your exam where it's done for you. Don't spend 20 minutes doing the calculations. If I tell you the test statistic, it's done. We just have to interpret that. So on this problem, we're looking at basically, does gender seem to influence your political party preference, Republican, Independent, Democrat? So my critical value, that's based off my degrees of freedom. Now remember, when we're doing degrees of freedom with a contingency table, it's rows minus 1, rows of data. So rows minus 1, there are 2 rows of data, so 2 minus 1. Looks like 21, let's try that again. There we go. Times columns minus 1. There are 1, 2, 3 columns of data. So that's really just going to give me 1 times 2. So 2 is my degrees of freedom. This is 0.01 significance. So for this one, 2 degrees of freedom all the way over to 0.01. 9.210 is my critical value. So my critical value is 9.210. Think about your curve. So I'm saying anything beyond 9.210 is weird. Weird means reject. My test statistic was 16.204, so this time chi-square is over there. So this means I'm rejecting the null remember the null is that the variables are independent. So I am rejecting independence. Oops, there we go. I'm rejecting independence, which basically is saying that it appears that political party preference does depend on gender. So there does seem to be a relationship between them. And you can see, if you compare some of these numbers, for Republicans, males to females, those numbers are fairly close. Democrat, the females are double the males on that one. So I can see that, yeah, there does seem to be some sort of a gender specific, some reason that the genders are going differently for Republican, Democrat. Independent, 50-50, even split. Okay, that'll do it for this first video. We'll do the last few problems on the second one.